Okay, I kind of did a hack job. I stole a bunch of stuff from before so that we don't have to cover it. I cover this up. No longer is it multiplying, it is now dividing rational functions. And nice big division sign so we can tell the difference. I factored this piece, we got it there. We factor this numerator, it's down here. Factor this denominator, factor this denominator. So we got all those pieces because that process, whether we're multiplying or dividing, is identical. So what we're going to do next, there we go, we're going to rewrite it. So we have 5x minus 2. Put our two division signs here. Over x plus 6, x minus 6. Then we have divided by. And the numerator was 4, x plus 6. And the denominator was x plus 7, x minus 2. Okay. Before we do this, this concept is when we're dividing, is the idea of dividing fractions. So let's say I have 3 over 2 divided by 1 over 4. Well, that can be written as 2 over 3 times 4 over 1. So what we do is we change the operation from division to multiplication because we know how to multiply. We do top by top, bottom by bottom, and the reciprocal of this. I sometimes call it inverting and multiplying. So now when we go to do that question, this would actually be 8 over 3 as an answer, as opposed to this one here, which was 2 over 12. Okay, very different answers when we divide and multiply. So we bring that back down here. This is a fraction. It just has some very large terms, and they're kind of split up. They're decomposed, you could argue. So before we go through the inverting and multiplying, our very first step is, hey, let's figure out what x can't be. Now, we've gone through that part before. We very quickly write, hey, x plus 6 can't be 0. X minus 6 can't be 0. X plus 7 can't be 0. X minus 2 can't be 0. And then we solve, blah, blah, blah. X can't be positive or negative 6. X can't be negative 7. And x can't be 2. Great. Now let's invert and multiply. So we're going to change this symbol to multiplication. Our first fraction, which is this big piece here, we keep it the same. We rewrite it. We got x plus 6, x, minus 6. But this one we find the reciprocal, or we invert, okay? So we now flip that around. Let's make that black. So now the denominator is on the top. I'm going to rewrite in red just so we know that there's change here. X minus 2. And the numerator is now the denominator. It's on the bottom. Now with this being said, normally what we have to do is check this. Now this can no longer be 0 also. So we say x plus 6 cannot be 0, but it turns out we've already dealt with that concept, okay? Had that been a new one, we would have had it added to the list, okay? Now, same concept as before, we're just going to simplify. Multiplication is essentially just putting all of these together. So I don't even actually really have to put those up. I can just take a look. Anything on the top or bottom the same? Well, let's see. This guy, they're both on the top. Nothing I can do there. And all these 6s are on the bottom. There's no similar one on the top. So I actually can't simplify this one. This one is set up to be the way it is. Now, there is one little piece I can simplify. And I can't, essentially, they call this like canceling out or creating ones. But I'll write this all as one fraction. X minus 2, x minus 2. I'm just going to put them together because it's going to help us see this next way of simplification. Even though we're not canceling anything out, I'll put that coefficient 4 in the front. And we have x plus 6, and x minus 6. Well, we have two sets of brackets. These two are identical, and these two are identical. You can represent those with just one bracket. You can say x minus 2 squared, x plus 7. And when it comes to simplifying, they will prefer you to do that. If you can see brackets that are the same, they're going to ask you to write it as a single bracket to the power of 2. Or in another case, if you have 3 of them, you would write it as the power of 3. So this would be your simplified version of it.